In section 5.8, we're going to combine the things that we learned about synthetic division and apply it to solving polynomial equations. Let's say we're given this function and we're asked to solve it. We're not given any information about other zeros or other factors of the function. We're just asked to find the solutions. As a first step, we want to list out all the possible real zeros, and we can get that from the equation itself. Notably, we want to look at the constant, which is the number at the end here, and list out all the factors. When we do that, we're going to ignore the sign of it. We're just going to treat it as a positive 6. And we're going to list out all the ways that we can multiply two numbers and get 6. For example, 1 times 6 or 2 times 3. So the factors of the constant are 1, 2, 3, and 6. Okay, the other number that we're going to look at is the leading coefficient. That's the number that's attached to the highest exponent in our function. Okay, the factors of the leading coefficient, the only way we can get 2 is 1 times 2. Now the possible real zeros come from taking those factors of the constant and dividing it by the factors of the leading coefficient. So we're going to take 1, 2, 3, 6, we divide them all by 1, and we take 1, 2, 3, 6, and we divide them all by 2. And we get these lists of possible zeros. Now when we list them all out, we see that some of them are duplicated. For example, 2 over 2 right here, that equals 1, which is already in our list. That being said, we don't really need to write that a second time. Same thing with the 6 over 2, that equals 3, and 3 is in our list already over here. Okay, so we don't need to write that. Okay, as a last step, our possible zeros could be positive or negative. So we have plus minus 1, 2, 3, 6, 1 half, and 3 halves. The zeros for this function, the real zeros for this function, will be in this set of numbers here. Okay, we won't, for example, get a 0 of 7 or a 0 of 4. That being said, let's list the possible real zeros for this function. So factors of the constant, which is 18. So 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work. Okay, and that's all of them. Factors of the leading coefficient, there's no number here, it's an invisible 1. So just a 1 for the leading coefficient. Okay, we take the factors of the constant, divide it by the factors of the leading coefficient. They're all divided by 1, so we just get those same numbers as factors of the constant. So plus minus 1, 2, 3, 6, 9, 18. So let's continue on with the same problem. So we have possible zeros of 1, 2, 3, 6, 9, and 18, and now we want to find the zeros. So what we're going to do is just one by one, we're going to go through this list of zeros, and we want to see which of these work to produce a 0 or a root in this function. If we plug it in, we'll get 0 as a result, or 0 as a remainder, however you want to think of it. Okay, we'll go ahead and do synthetic division since it's easier. So we put in our coefficients from our function, okay, and let's start with the smallest number in our list since it's the simplest. So we'll put a 1 on the outside, and then we go through the synthetic division process, which, as a reminder, multiply these two numbers, write it there, add these two, we get -3, and then just repeat that process over and over again. 1 times -3 is -3. Added together, we get -18. 1 times -18 is -18. Now, this is what we want to see. If it's a 0, we get a 0 as a remainder, which means 1 is a 0. Okay, keep in mind that when 1 is a 0, the actual factor is x minus 1. So if we rewrote this right now, we would have x minus 1, and then this gives us what's left over, x squared minus 3x minus 18. Okay, let's keep factoring to find the other remaining zeros. We want to look at this and we want to earmuff this. Okay, two numbers that multiply to -18, add to -3, -6, +3. Okay, it's the easy earmuff since there's no coefficient there, it's just a 1. So we can take each of these numbers and put it right into parentheses, x minus 6, x plus 3. Notice I'm not changing the sign for these. Okay, I just keep them just the same. Okay, if we were talking about the zeros, it would be the reverse of the sign. So right now, fully factored, we have x minus 1 times x minus 6 times x plus 3. We want to find the zeros, so we just take each of these, we set it equal to 0, x minus 1 equals 0, x minus 6 equals 0, x plus 3 equals 0. They all just change signs since these are simple equations, and we get our answers 1, 6, and negative 3. When you look at these and you compare it to our list of possible zeros up here, you should see that all the three of those numbers are in that list of possible zeros. Let's do another one. We'll start off by listing the possible zeros. Factors of the constant, 1 and 25, 5 and 5. Factors of the leading coefficient, just a 1. So we have plus, minus, 1, 5, and 25. Right? Now we want to walk through and find out which of these are the actual zeros. Note that in our function, it skips over the x cubed. It goes from x to the fourth right to x squared. There's a 0 x cubed in here. So when we write our synthetic division, we have to put the 0 x cubed. Okay, let's start with 1. Carry down that first one. Okay, and then we just do that same process. Multiply. Add these together. Multiply again. This time we get 0. Add these together. Negative 16. Multiply. Add. Multiply. Add. So 1 is not a 0. Okay, at this point, you can choose whatever you want to do next. I usually go all the smallest numbers, so I'll do 1, negative 1, 5, negative 5, etc. If you're better with positives, you could choose to do all the positive ones. It really doesn't matter. Okay, but we have to keep going until we find one that's a 0. Sometimes if you choose the wrong numbers, it could take a while. All right, I'm going to do negative 1 next. So we multiply that, we get a negative 1. Add them together, multiply again, positive 1. Added gives us negative 15. On and on. And we see that negative 1 is a 0. Okay, if negative 1 is a 0, it means x minus negative 1. Okay, or really x plus 1 is the factor. So x plus 1 times x cubed minus x squared minus 15x minus 25. Okay, this is not something we can factor, which means we need to do synthetic division more. Okay, so we're going to do it again with just these numbers. We don't do these ones anymore because we found a factor. We're going to use the remaining factors. All right, whatever we tried that just works, we want to try again just to make sure it's not a double root. For example, it could end up being x plus 1 squared, okay, or cubed, or to the fourth. All right, so when we go through this process, multiply, add, not a 0 this time, okay, which means that this one was a 0. That leads to this function over here, okay, but it didn't work a second time. We're going to try the next thing in the list. We don't want to try this again because it doesn't work, so now we're on to the 5. Okay, so carry down, multiply, etc., etc. And we see that 5 works. All right, that's the 0. So x minus 5 is the factor. Here's where we are now. Carried over from the previous slide, we have this equation, which includes the factors for the two zeros that we found, negative 1 and positive 5. And then this leftover part, which we're now going to look to earmuff. When we do that, we'll see that nothing actually works. Okay, it's close to working, but if this was actually the set of numbers that worked, this 5 would have to be a negative, and it's not. So earmuffing doesn't work. There's no solution as far as earmuffing goes, but we do know other methods such as quadratic formula. Okay, plug everything into quadratic formula. I'm not going to walk through it step by step other than to remind you that it's best to do the discriminant first. 16 minus 20, that gives us a negative 4. Once we see this is negative, we know it has an imaginary answer. It's going to have an I in the answer. And fully simplified, we end up with negative 2 plus minus I. The 4 solutions are from the previous slide, negative 1 and 5, and then the 2 answers that we got right here with quadratic formula, negative 2 plus minus I. Note that this is a 4th degree function, and there's 4 answers here. In the previous example, it was a 3rd degree function. We had 3 answers. Okay, if it was a 5th degree function, it would be 5 answers, etc.